Welcome to The Bootloader. I'm Paul Cutler.
And I'm Todd Kurt. We have a special episode today as we welcome guest Kevin Cappuccio, creator of the Jumperless breadboard. Kevin, welcome to the show.
Nice to be here. Thanks for having me on.
We each have brought 2 things to share. We'll chat about each one for a couple of minutes, but no more than 5. If you want to learn more, visit the detailed show notes and transcripts at thebootloader.net. Kevin, before we start, let's talk a little bit about this Jumperless V5 that the crowdfunding campaign is going on for.
I made the original Jumperless about almost exactly a year ago, and I hacked in this probe thing. So what makes the Jumperless V5 so much cooler is I added a probe that lets you just poke out connections. And it was like, once I did that, I was like, oh my God, this is the way to use this thing. It's so much nicer. So I just started over, used all the cross-point switching matrix to make all the breadboard connections in the back, kept that. And then, so V5 is just making it really like intuitive, a nice UI to do whatever.
It looks so cool, especially with all the LEDs behind each breadboard point. So like as you touch the probe, they light up. That's great. Did you use these 446? I lost the chip now. The analog crossbar switch that's like 128 switches in this little chip. Did you use that on the previous Jumperless as well?
Yeah. So like early prototypes, I was using an old Mitel 8816, MT 8816. And so turns out, but they're like big PLCC packages. They're like huge, like ceramic heavy chips. So I couldn't fit more. And so I went looking. Turns out the CH446Q is kind of a clone, but they like made it a lot better. Like it's kind of cool to see companies doing that where they're like, they take the same thing and then they're like, we need a serial addressing mode. So like you don't have to send a bunch of parallel data and run a bunch of wires. You can just, So I use those. They're great. I use them way out of spec too.
Yeah, I'm a big fan of these analog multiplexer chips to like basically let you turn one analog input into 8 or something. And to see this cool, it's got 16 lines on this side and 8 lines on this side, and you just connect any one to any of them, and even have multiple ones connected. It's kind of blew my mind. It's like, I want to play with this chip for something. I don't know what yet.
Yeah, they're great. They also make a 5x24 version. Like if you want to like really fan out.
Cool.
Still haven't found a use for them, but I want to.
So the other difference in the Jumperless V5 is that it's got the new RP2350 chip. Have you liked that chip? This is one of the first designs I've seen actually use it.
Yeah, so they make it in a bigger package, so you can get that extra GPIO was so clutch. Like I had a GPIO expander on there. It was like driving the chips, and it's so nice to be able to take that out and just, instead of sending an I2C message to it or something, like you can
becomes a lot simpler. Yeah.
The beta test units that are out right now, like those were handed to me as samples at DEF CON, like because they launched it at DEF CON. I was like, no way, I have to do this. And just spent all of DEF CON reading the data sheet like a couple times over.
Totally.
I was wondering where you got the 2350 because no one else has them, and I was so shocked to see a new product with them.
Yeah. I was one short for them, and I bought a Pimeroni board with it on and just desoldered it and put it on
Yeah, because I think Pimeroni is the only place you can get the bigger version of the RP2350, I think.
Yeah. It adds some, there's more pins, more ADCs and stuff, but really it's just cool. Like I just did it 'cause I was like, this is going to be awesome to have the newest chip on there.
Totally. Well, I mean, it's a good marketing move, even if you don't need the extra CPU power and stuff. It's just to say, hey, I'm using this new shiny new chip that everyone's all agog about.
Yeah, I mean, and it just gives us, eventually we'll probably need that room because keep getting all these app ideas in the Discord. Like we should have a Python REPL on it. Like,
yes,
sure. Why not throw that in there? Like we got so much room.
Yeah. Do protocol decoding or something.
We do that. That was actually this entire week. We were doing protocol.
Oh, really?
Serial pass through. So now I can there was an update that just got sent out on CrowdSupply, but we were screwing with it for this last week straight of getting serial pass through so you can route UART lines or any or I2C or something, and then anything that comes in through the second USB endpoint will just get like bidirectionally passed right through. So you can put like an AT Tiny on there and you can just flash it as if it was plugged in by itself. It's kind of cool.
Oh man, that's cool. Yeah, because normally you got to pay like a bunch of extra money on your scope to get protocol debugging, and if this is part of your breadboard,
it's not as good as a scope. Let me set expectations right there. It does a lot of things. It does not do any one thing really, really super duper well.
Once the probe thing came out and you're touching stuff and lighting things up, I'm like, okay, this has got to be a synthesizer or a synthesizer interface device or something, because it looks like something out of a sci-fi 1970s rack mount synthesizer thing.
I was going to sell a second synthesizer version, which is exactly the same thing, but twice the cost.
Hey, now.
For those at home that might be curious, how much is the Jumperless V5?
It's $350 while crowdfunding is going. And then as soon as that's over, which by the time you hear this, it will be, then there'll be $379.
Okay.
Yeah.
Well, I'll make sure that we link to that in the show notes too, so people can check that out.
Totally. Yeah, this is very cool.
What's the first thing you brought us this week, Kevin?
So I brought the UNO++. Looks kind of like a regular Arduino UNO, but every pin has an LED on it, and it tells you the state of each of those pins. So like if it's, pins high, that actual row is lit up. And how he does it with the actual like plastic header is it's a clear plastic bit and it acts as a light pipe. So like it's not just an LED next to the header that's lighting up, it's the whole part of the header lights up.
That's pretty cool.
Yeah. Something like this, okay, if I had just seen it and I didn't see the schematic, I would not trust it in a million years. Like the easy way to do this would be put another microcontroller on it and then just read all those inputs and then send it to some addressable LEDs. But John, talk to him, he can't program. So he instead did it the cool way and did it with comparators. And so it's a ton of, quad LM339 comparators. They've been around forever. And so like that I would trust. Like if that's on, there's really not much that could go wrong that would tell me the wrong state.
Yeah. And it buffers it so it doesn't impact your use of the GPIO pins.
Yeah, exactly. And he even like set the comparators right. So like with the hysteresis, like, they won't go over 1.8 volts, what they're supposed to, it's cool.
That's awesome. Did he get like custom headers made instead of the black plastic? They're clear light pipes or?
Yeah. So I was just talking to him, and what he was doing a clear 3D printed transparent like resin, and then having a second 3D print that slots into it, like really thin little blades that keep the light separated from one to the next. So it's got a really tiny channel. But JLC now, I was just looking on JLC the other day, and they do like full color resin, like clear resin, and then you can put color inside it. So now it can be one part. Yeah, JLC.
That's pretty neat.
Yeah.
Wow. So is this a thing that you can buy, or like does he have also a crowdfunding campaign going?
No, so he's close. He's getting there.
Ah, cool.
I don't even think the Hackaday.io project that I linked, I don't think that has all the newest things. I think he's now using full color PCB. Mm-hmm. But no, it's coming out soon, and it's going to be rad. And
that's awesome.
Hopefully I can convince him to make a Arduino Nano version, but that's going to be so much harder.
Oh, because then that will plug into the Jumperless board.
Yeah, exactly. Right. I mean, like, it sounds like a little beginner learning tool, but like 99% of my debugging is this pin actually doing the thing I want it to? Like, yep. Is it the pin, or is it the code or something?
Yep. Like 90% of the times when I'm helping people with coding projects, I just tell them put print statements like in between every line so you can see what's going on, and they're like, oh. And but like you can't do that because it'll slow down your code, or it's just like unfeasible. Having LEDs, like physical representation of what your circuit's doing, is like so much more clear.
Yeah, it's funny walking people through debugging stuff, and you're like, no, check again, check that that's up. You know, like, no, the code says digital write hi, and you're like, no, dude.
Not really.
Yeah.
You didn't set the pin to an output or something.
Yeah, exactly.
Very cool. I can't wait to see more of this. Uno plus plus, and it's spelled PLUS plus sign.
Yeah.
It's hard to search for if you don't know that.
Yeah. I actually genuinely thought I was going to lose the Hackaday prize last year to that. Like, that was the project I was like, that's cooler than Jumperless. Like, I would vote for that over my own.
I don't know. They're both pretty cool.
Yeah.
All right, Paul, what's your one for this week?
Mine is the Manyfold app by James Smith. Manyfold is an app that's been around since 2021, but it's been in the news recently because it just added ActivityPub integration, which I'll come back to in just a minute. It's a self-hosted app built to manage and organize your files related to 3D printing. It's open source, released under the permissive MIT license, and written in Ruby on Rails. Imagine Printables or Thingiverse, but self-hosted. You're not locked into another walled garden. And it has some really, really neat features. You can run it as single user or multi-user. So if you're running it in single user, you're just keeping a track of all the files that you have. Multi-user, you can invite other folks to join your server, almost like PixelFed does for sharing photos. I mentioned earlier that it's integrated with ActivityPub. That means it's on the Fediverse. Imagine being able to follow a creator or a model directly from your Mastodon account, which I think is really, really cool. So every time that model is updated, you'll get a notification, I believe. I need to double check that. And then one of the other cool things about it is it doesn't just handle the 3D printing file formats like you would expect, such as STEP files, STL files, and 3MF files. It handles everything related to 3D printing. Every image format is supported, from JPEGs to PNGs to GIFs to SVGs. Video files are supported if you want to show a render of the 3D printing model that's going to be printed. And it can keep track of all the text files that go with it. So if you have installation instructions, for example, it'll have all of that built in like you would expect it to. If you want to learn more about it, I've linked to an interview with James and the Floss Weekly crew on their podcast. You can check it out at manyfold.app, and there's a demo server at try.manyfold.app to see it in action. It's really, really neat. I highly recommend it.
That's cool. I love seeing more things that we think have to be monoliths being added to the Fediverse in some way, because, like, why not? Like especially for something like Thingiverse and printables, you know, fundamentally it's not that hard. It could be an FTP server.
It could be, but you know, if you're running one of the servers, one of the things you might need to think about is copyright violations, right? What if you have a file that's copyrighted? Or I think James mentioned in his podcast that he buys or subscribes to Patreon creators who, if you subscribe to them, will give you files. Well, you're going to want to make those private, for example. You don't want to make those public because those were for sale. And all that functionality is built right into Manyfold.
Yeah, and just seeing updates. Like, you know, sometimes you get a file that someone made and then you forget that, like, maybe they tweaked it, made it better. I don't know.
Exactly. I think that's one of the coolest things about it being on the Fediverse like that.
Yeah, and back in the heyday of Thingiverse, one of the things I really liked about some of the models is the discussion that was going on a model. People were like, oh, you know, what's the right way to print this? And there'd be like discussions on, like, you know, different filaments or different orientations of the part or whatever. And like, if it's kind of part of your Mastodon experience, that conversation can happen pretty seamlessly, I would imagine.
Yeah, I don't know if that's enabled, but it's definitely something to check out.
Yeah.
All right, Todd, what's your first one for us this episode?
All right. So some of you might have already seen this, but to me, it was just like kind of a little bit mind blowing. Like, we've all seen the Doom game ported to insert tiny electronics like the watch or the little Arduino or something. But
or the Jumperless.
Yeah. Oh, is it going to have Doom?
Yeah.
and that's great. You know, it's like a really complicated game engine compared to like things like Pong, but it's not true 3D. It's more like a 2.5D where the enemies are just sprites and the level geometry is just perturbations on a 2D plane. But the game Quake, which is the game that came after from id, was full 3D, fully polygonal monsters and objects in the world, fully polygonal game world. And I figured Quake would never be part of these little tiny embedded things. But I saw a couple days ago that people at nexthack.com got Quake running on a SparkFun Thing Plus Matter board, which is a feather format board, you know, 0.9 inches by 2 inches. And it's only got It's a 39 megahertz little board that's got 256K of RAM and 1.5 megas of flash. And this is the same specs as the RP2350 pretty much. So, are we going to see Quake on, the Jumperless or on a Adafruit Feather soon? So first they started with a SparkFun board, and they made a little sort of prototype that you can build yourself. They've included all the source, but then they created their own gamepad PCB that houses an Arduino Nano matter. It's like this uses the same chip, this MGM 240 module that has a Silicon Labs EFR32MG24, and it's some Bluetooth Matter chip that's pretty cool. And they got this whole complete package that has a screen, has the Arduino Nano on it, buttons, sound output, and it runs at 35 frames per second at 320 by 240. Oh, and also you can do BLE-based multiplayer with someone else with the same board.
Oh, that's amazing.
Yeah.
Oh my god.
Yeah, and so like as someone who sort of got into PC gaming by buying the 486 with the 4 megs of RAM minimum, and like having that be such a stretch back in whenever it was, and now to see that, oh wait, they could have done it in 256K of RAM. It's pretty amazing. In the show notes, we'll have links to their multiple posts they have on this, a write-up from the Silicon Labs tech blogs. They really liked it. Links to the design files if you want to build your own of these boards. It seems pretty doable.
I love this project. Quake always has a special place in my heart. I was a big gamer in the mid-90s, or starting in the mid-90s, and I had a 3DFX Voodoo card. And one of the top 5 gaming memories I still have is the first time I had that card in my machine. And in Quake, you walk up to the puddle and you see a reflection of the character in the puddle in full 3D. It's something I'll still never forget because it was just mind-blowing. We didn't have graphics like that until that card and that game came out.
Yeah.
So it's pretty neat to see how far that's come in the last almost 30 years.
Yeah. For me, one of my memories that comes back unbidden to me is being able to bounce the Quake grenades around the corner to kill monsters, and the noises that it make of the dunk 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 as it bounced around. It's just like, oh, you can kind of think strategically in this first-person shooter game.
Like, what if someone came back in time and told you that that chip is in a smart light bulb,
right?
Or something? I just throw them away. It's easier to just put that whole thing, something more powerful than your computer.
It's like I saw Seed just came out with a Zhao format, like a QT Py format board with the same chip for like $7, and you're not going to be driving a really like high res screen with that, but hey, maybe it could run Quake.
Yeah.
All right, Kevin, what's your number 2 for this week?
Yeah, so this one's it's not a project. Like I'm bending your rules a bit, I think. But it's a field. So like the field of evolvable hardware. It's literally as old as I am. So the first project with evolvable hardware was University of Sussex, Adrian Thompson. What he was doing was, in 1990. So what he was doing was like getting an FPGA. So I think he was using a Xilinx XC6200 and basically giving it a fitness function. So I think the seminal thing that he did was a tone discriminator. So being able to tell the difference between 1 kilohertz and 10 kilohertz on, I think there's 100 gates. It's like a 10 by 10 FPGA. And so he would just say, is it okay at that? And then it would give it a random bit stream, just random arrangement of a bunch of logic gates. Yeah. And then, at first it's probably just kind of up in the air of none of them are doing the right thing, but then over time, he's doing like an evolutionary thing where he's like the 2 most fit ways of getting, making this pin go high at 10 kilohertz and low at 1 kilohertz, do that again, and then put some randomness in it. And he ran it for a while and it worked. Like it just found, and it's like, if you look at the arrangement of gates, it's complete nonsense. like there's parts that are not even connected to anything, but are necessary for it to work. Like it's using kind of just like the weirdness of like signals going, like, there's no constraints. You don't have to abstract anything. So it's just, Like, yeah, it's using, and it probably wouldn't work on another one.
Yeah.
Like if you put that exact same setup, it wouldn't work on a different chip because it's just, but yeah. And so running circuits like that would be, I don't know. I just think it's the coolest thing ever. But yeah, so what happened though was why I feel like it's kind of relevant now is they stopped using, like they discontinued the Xilinx XC6200. And now all the FPGA bit streams are like encrypted. They're like all, they're very proprietary. And what you need to get this to work is kind of just I know one-to-one of if I say top left corner logic gate be that, it'll be that. But what's cool now is I hope that there's a resurgence in this because have you heard of Project Ice Storm?
I have not.
They're reverse engineering the bit stream of a Lattice FPGA, like a modern one.
Okay.
And so like we had 30 something years of like basically this whole field is kind of dead. Like there just wasn't like hardware for it. And only now like we can pick up again. People can screw around with trying to get, is it the best way to do something? I don't know.
Well, I have to imagine too, it's a lot cheaper now to do it than it was back in 1990.
Oh yeah. Yeah.
Yeah, those little ICE 40 FPGAs are pretty cheap. I see them pop up on various Arduino looking boards and stuff. So, and if it's just set it up and let it run, and
Yeah.
call me when you figure it out. That's pretty great.
Yeah. I mean, like I think there was some interest from like space stuff, because if you broke your FPGA, like physically broke it in half, you might be able to get one that runs on just the rest of it, Like,
yeah, totally.
That's
yeah. It's like how do you make resilient circuits? Like right now we design things very sort of cathedral, where like every bit has its own important part to play, and if one bit is missing, the whole thing doesn't work. But if we can make something that can recover, that'd be pretty great.
And fun fact, in the book 2001: A Space Odyssey, that's how HAL was programmed. Was like he described some process just like that, where they.
Oh wow.
Yeah. So Jumperless, like the first idea of it came after me going on this rabbit hole for like a really long time about evolvable hardware, and it was kind of frustrating because it does like, there's a lot of work on it, and then it kind of just fizzles out, because they discontinued the chip, and it was like other universities weren't able to screw around with it as much. And so that was kind of part of my thinking of like something you could do with this whole analog crosspoint switch array is you could, like, it's not going to be a feature like you would just be able to just run it and it would try to fight a circuit, but as a thing to screw around with,
that's pretty cool.
Good for that.
Plus, on the Jumperless, it could look cool because you could have the LEDs represent the connectivity that's evolving over time or something.
Oh, yeah.
All right, so Paul, what's your second one for this week?
My next one is a current Kickstarter project that's going on for a few more weeks for the FlexiPi. It's a new Raspberry Pi Pico format board, but it's wafer thin and it's flexible, hence the name FlexiPi. It's got a few upgrades from a normal Raspberry Pi Pico. It uses USB-C. It's got a NeoPixel built in. Otherwise, the pinouts stay exactly the same. The Kickstarter campaign runs through November 24th, and it includes 3 digital books that come with it, getting started with the Raspberry Pi Pico, a MicroPython book, and a CircuitPython book. They've already reached their funding goal. Their goal was $500, and they're over $7,000 already. But if you do back it, remember, it's a Kickstarter, so nothing's ever guaranteed. But it's really neat to see how flexible that really is. And I don't understand how they got it so thin, but it's something that I want to keep an eye on going forward.
Yeah, Flex circuits are pretty cool. It's like this is really impressive. I don't know exactly how I would use it. I mean, I don't really do much Flex stuff, so
wearables are the first thing that came to mind for me.
Yeah, definitely that.
Yeah, someone actually dropped that on my Discord just a couple of days ago, and it's funny because I can't think of what to use it for, but it's really fun to think of situations that it would be useful.
Yeah,
like, there's so many like what weird problem you're having where you're like, oh, I just wish this Pico could bend.
Exactly. Yeah. And I should mention it's $20, so it's not cheap compared to a normal Pico, but that's what you get for having something that's so thin and flexible.
Yeah, and just having a little bit of give on something that you wear could be all the difference. Like, it doesn't have to bend much, but maybe just a couple of degrees could make it not be like, oh, look, he's got a piece of technology embedded inside of his hat or something.
Right. All right, Todd, wrap it up for us.
All right, so my second thing is the EMMG MIDI synth, and is created by a hacker in our sort of larger community. This guy named Jonathan Bisson, or Bjon J. It's a board he created as a teaching tool for a workshop he gave on MIDI and music synthesis at the Pumping Station 1 hackerspace in Chicago. In the show notes are links to the presentation and other aspects of the project. The workshop taught what MIDI is, down from the signaling level to how it's used by performers. Each student of the workshop got one of these custom designed boards. The board has 8 pots, 12 CapTouch pads, an OLED display, and stereo out, all driven by a Pico clone that's a USB-C 16 megabyte version. The workshop also talks about how the GPIOs work on the Pico, how CapSense works. Looks like it was pretty fun. And the board has a secret mode. By default, it comes up as just a MIDI controller, but if you power it up with one of the switches held down, it also is a full synth using this interesting Pro32U synth engine for Pico that he found. And he was able to, it's like an Arduino chunk of code, but it's really cool. It's got like it's a paraphonic, polyphonic, 4 voices with built-in chorus and delay effects, a really cool filter. It sounds pretty good. Selfishly, one of the reasons why I bring this up is because I have one. He sent one to me.
I was literally just about to ask you that.
Yeah, he based the design of this board on a couple of my previous projects, most notably the Pico Test Synth, the Pico Slider Toy, and this sort of unreleased thing I have called 8x, which is a sort of 8 pots to 1 analog pot sort of expander board for microcontrollers. And his board, by having 8 pots instead of 2, solves one of the biggest problems I've been struggling with my little Pico Test Synth as I try to write code for it for people. And that's having only 2 pots when you need to control a whole slew of values is a real pain in the butt, because you have to keep saving the state of where the pots are currently when you switch which parameters you're changing. And then you have to like deal with the fact that like when you come back to that parameter, the current location of the pot is not where the pot physically is, and so you have to like deal with like what's called knob pickup and stuff. It's just a real kind of pain in the butt. So with 8 pots, you can like have immediate control of a bunch of parameters without having to do a bunch of page switching and stuff. I think if I were to redo the Pico Test Synth thing, I would have either more pots or use rotary encoders, which is why you see a lot of rotary encoders on things, because they're incremental. You can just show the state immediately, and just any turn of the knob will just increment or decrement the state. All of the designs for the board and for the workshop notes and presentations are up on GitHub, and I'll put links in the show notes. He also has a really great sort of blog post that describes his whole design process, including like the DFM of like how do you make this thing actually buildable, and also the OpenSCAD CAD files for the custom knobs he made for the board. is pretty nice to get some sort of like free stuff back for all the random little circuit boards I've made over the years.
That's pretty cool. And you said it runs Arduino?
Yeah, the main code he has is Arduino. He's also got some experimental stuff for CircuitPython, but he started down CircuitPython route, but wanted to have something that was easily able to switch between these 2 modes, and he wanted this synth engine that was based on Arduino.
I love the idea of making a board for a workshop, like, because now like the person giving the workshop knows exactly how that board was made. You know, yeah. Like you'll never run into a question of like, oh, why is it like this? And they're like, I don't know. Like,
yeah, I wish there was video for it, because I kind of wanted to know like how did he have everyone hook up the boards? Like, were they all controlling like a synthesizer in the room or something? I'll have the slides, and I haven't asked him about it.
It's just probably like a loud mess in that room of
each person right.
doing their own.
Well, that's our show. Special thank you to Kevin for joining us this episode.
Thank you so much for having me. That was fun.
For detailed show notes, transcripts, and to join our newsletter, visit thebootloader.net. And until next time, stay positive.